Hello everyone, how are you all? I hope everyone is going great in their life. So, in today's video, we will start with the intro part of inductor. In intro part, we will discuss in further slides the definitions, the technical terminologies related to the inductor, all the terminologies, technical terminologies, definitions and units, SI units, and the properties of inductor. And the properties of inductor. So we will discuss all these so that a basic understanding, a fundamental understanding of inductor will be there in all the viewers. Fine, so we'll move to next slide. So this is the first slide of inductor, in which I've been adding to this definition part and a simple basic diagram. So what is the definition of inductor? It is a two terminal device, means it is having first terminal and it is having second terminal, which stores energy. So the basic thing is inductor stores energy. The highlighted point is this: magnetic field. In the magnetic field, when electric current flows through it. So I'll tell you the basic parts first. We will take a core. So this is a core in which we have wound this iron coil. So in a core, when we wound the iron coil, and when we supply current through it, that is the flow of current from first terminal to second. So when we supply the current to the coil which is wounded on the iron core, the magnetic field will generate around this coil. Magnetic field will generate around this coil, and this magnetic field, by this magnetic flux will be generated. Magnetic flux will be generated, and from this magnetic field, energy storage will be done. Energy storage in the form of kinetic energy. In the form of kinetic energy. So it is as simple as that. When we wound a coil on an iron core and when we give a supply to the first terminal of the iron core, the flow of current happen in the core, right? And when the flow of current happen in the core, in the iron coil, the magnetic field will generate, and the magnetic field leads to a magnetic flux around it, and that magnetic flux leads to the energy storage, the kinetic energy storage in the iron coil, right? So this is basic of inductor, that's why we call it as an inductor. So what is inductor? It is a two terminal device which stores energy in the form of kinetic energy in the magnetic field, because here in the inductor section we will always discuss electromagnetic field, and in capacitor we will always discuss the potential energy, right? The potential energy or electrostatic field we discuss. In capacitor we'll do with the electrostatic field, and in inductor we'll do with the electromagnetic field. So these are the differences between the capacitor and the inductor. Fine. So this is the basic understanding. So this definition is important. I'll discuss again with you all so that a good understanding will happen to you. It is a two terminal device, right? It is a two terminal device which stores energy in magnetic field when electric current flows through it. So we want to flow the electric current through this coil which is wounded on a core which is wounded on a core. Electric current, as electric current flows through it, magnetic field generated around this coil, and that leads to the develop of magnetic flux developed. And that because of that magnetic flux, because of the changing current in it, energy will be stored in the coil, and that energy is kinetic energy, which will be given by the formula half Li square. We will discuss this formula in the further slides. So okay, that's all for this slide. Now go to the next slide. In the next slide, we want to know what is inductance. What is inductance? So the first point for inductance is it is a magnetic energy storage capacity, as we have discussed before, that inductor actually store energy in the form of electromagnetic, in the form of kinetic energy in electromagnetic field, right? So the kinetic energy it is stored, the capacity of this energy storage, capacity of this kinetic energy storage will be called as inductance of inductor. So inductance is actually the property of an inductor. And what is inductance? Actually it is the energy storage capacity of a inductor. Fine. So it is given by di by dt because it actually opposes the change in current through it. When a conductor opposes change in current through it, change in current through it, it will be called as inductance of inductor, right? Inductance of inductor. So what does it mean? In the resistor part, in resistor, it actually opposes, it opposes current flow through it, current flow through it. And in inductance it opposes change in current through it, right? If it is 2 ampere and we want it to shift 1 ampere or 3 ampere, inductor doesn't want to change it 1 ampere or 3 ampere. It want to maintain its current as 2 ampere only. So the change in current it actually opposes, and that's the tendency of an inductor, and that leads to the energy storage capacity, which we called as inductance. Fine, so that's all for this slide. We'll move to the next slide. So what next slide, in what we explain the next slide is SI unit of inductor, right? So firstly we will do with the symbol. So what is the symbol? This is the coil, and that's all. We will represent it with capital L, and that's all, to understand that it is we are talking about the inductor part, right? Same for resistor. This is the symbol of resistor, this is the symbol of capacitor, charging plates are there, and for inductor we use a simple coil. Fine, and we denote it with capital L. Now inductor is represented by L. We have discussed it. SI unit of inductor is Henry, that is capital L. So what is 1 Henry? If there's a question, the exams or wherever you are working, that what is 1 Henry, if you want to know it, so it is very simple. 1 Henry is the value of self inductance in a coil in which 1 volt is produced by a variation of the inducing current of 1 ampere per second. So we have to induce a current of 1 ampere per second in the coil. In this coil we have to induce 1 ampere per second current that will lead to the generation of 1 volt. And in this coil, when 1 ampere per second is induced and a 1 volt voltage is produced, the value of inductance will be 1 Henry. So it is as simple as that. We have to put the value of current and time, that is second, 1 ampere in 1 second, and the voltage will be also 1 which generates, and the inductance part will be 1 Henry. Fine. So this is the basic definition of 1 Henry and the SI unit and the representation of inductor. We'll move to the next slide. Okay, so here in this slide we will discuss the properties of inductor. Properties of inductor, we'll discuss the passive element first. It is a passive element. Why it is a passive element? Because it works as a load and as a source, depends on the energy stored in it. Like when we add this inductor in a circuit and it is having zero energy in it, it is not charged, it is having zero energy in it. So in the circuit it works as a load and it starts charging, through the circuit, whatever we supply to the circuit, right? And the same coil after charging we use in another circuit. Now it's being charged and it is having some sort of kinetic energy in it, right? So it is having some kinetic energy in it, and we use it in a circuit. Right now it is being charged, so it will work as a source in the circuit. It will work as the source in the circuit. So there's a difference between the two. When it become a load and when it become a source, it all depends on the energy stored, whether it is charged, it is having some sort of energy in it, or it is discharged or zero energy in it, right? So that's why I called it as a passive element. Now the second point is inductance. So we have discussed it that it is a tendency to oppose change in current through it, like it doesn't want to change of current in it. So that's why the tendency to opposing this, that is called the inductance. Linear element, just like the resistor, when we make a graph of V and I, so this will give the resistance part and it will be linear always because resistor is also a linear element. The same thing happened with the V and di by dt, the change of current, and this will give the inductor part. Fine. The inductance will be there and it will a linear graph will get. Fourth point is dynamic element. In dynamic element, because it is the capacity of storing energy in it, whenever there is a element which stores energy through it, there is a capacity in it to store the energy, we call it as a dynamic element. SI unit of inductance, we already have discussed that it is an Henry, which is denoted by the capital H. Kinetic energy storage is half Li square. This is the formula of kinetic energy stored in inductor. Fine. And this L is inductance and this I is current flowing through it. The square of the current is used in the formula part. That's all for today's presentation from my side. Thank you. Thank you everyone for listening this whole presentation.